Okay, cool. All right, so I'm going to go through a demo of this IBC chat app and then talk a little bit about the technicalities and some of the setup and deploy scripts and a little bit of code and all that kind of stuff. So first, just from the user experience, once everything is set up and you've got a relayer running and everything, so when you run the front end, each of these client windows will connect to a different chain. And what's happening is Neutron is acting as the server. So there's a client contract deployed to each chain and then a server contract deployed to Neutron. And so what we'll see is that when we send a message from, let's say, Kujira, hello, right? We're going to create a transaction on Kujira, and we'll immediately see it on that server. And then eventually the relayer will pick up the event. The relayer will pick up the message, send it over IBC to Neutron. Neutron will then send it over IBC to Noise and Stargaze. And of course it works, from either direction, from any client to any client. Here it's executing on Noise, and we'll see that, it gets sent there, and then it's picked up over IBC, sent to Neutron, and, broadcasts out. Now what's actually happening in the front end is that each of these windows, to display the message, it's just, kind of querying the state on a loop. But on Neutron, it's actually querying every block and parsing out the events to show the events that are coming through from anywhere. That's so we could see all this stuff, even though there's no input here and it's not a client contract. So that's high level chat over IBC, super cool, right? Okay, now just to kind of, I think that's really it from what it is. But let's show one more thing. I'm gonna bring over the terminal here. 1 second into the window if I can do that. And yeah. All right. So here's just the relayer running. I'm gonna create a new tab here, and okay. All right, so now if I run on-chain tests, right? So task on test on-chain local. So this is going to run the on-chain tests in Rust, which we'll talk about in a minute. And kind of the cool part is that as it's running, let me start to see it run. We should see both that the tests are running, and we should actually see the messages updating in the front end as well, because it's it's sending messages to the same way. So yeah, it's cool, right? It's testing all the message sending and everything with on-chain tests. I'm just gonna get this terminal out of the way a bit so you can see it kind of happening. So yeah, I think that's kind of cool. Yeah, I guess we'll let the tests finish. What it's doing is it's just sending from each client and then making sure that, it's for each client, it's sending it from the other clients and making sure that each client gets it. So it's just a robust on-chain test suite, I guess. Yeah, all right, let's let that finish. Okay, great, it's finished. Now, let's shut down the relayer and talk a little bit about the scripts. If we go to the README, you'll see there's a lot of documentation about the prerequisites and setting up the local chains and all that. But once you've gone through that initial setup of you have the Docker images and you have all the tooling installed. So let's go really crazy. Let's not just wipe the contract state or even the chain state. Let's delete the Docker containers completely. So if I see here in my Docker desktop, we'll see I have all these instances, and we have all these volumes. So let's just task chains delete, and that should have wiped it all. Yeah, so we have no more containers, no more volumes. It's all gone. So yeah, our front end should be absolutely dead now. Yeah, we got a panic. Okay, fine. All right, so now we're kind of acting as though, and let's go even crazier. Let's go to a new, I created this brand new, instance of Chrome, and all I did was add the Kepler extension. Let's hope I remember the password. Yeah, okay, great. And it has no local chains, nothing is set up. We're talking now basically everything is completely fresh. All right, so first of all, let's create all the chains. Task create chains. I think that's it. 1 second. No, let's look at our task. Chains create. Okay. Task chains create. Boom. So it's going through, it's creating all the chains, all the Docker stuff. And what's really important here is that it's using the values that are set in our network.json file. So for example, we've set a 1 second timeout for all these local Docker containers. We're affecting the timeout. We've set all where the chain dir is. And it's all using that like config. So it's all consistent. And it's also using the seed phrases here. It's creating a seed phrase for each of these. So in our .env, we get, a consistent seed phrase. So for example, user seed phrase, we'll be able to use the front end across all these chains. We don't have to worry about like the different setup scripts, and all of them have cores enabled. So there's a certain consistency in all the chain setup that all we had to do is do, what was the command? Task chains create. Great. So now we've created all the chains. It's now, all in Docker. So now let's do task chains start. Okay, cool. All the chains are started. Now let's say so if we look at our deploy.json, which should never be edited by hand, this is like created and edited, updated automatically through the tooling. So you can see like all these are obviously wrong. The code ID can't possibly be 30 or 9 because we've got fresh chains. So let's redeploy all the contracts. Task contracts deploy local. Okay, so it's going to recompile and redeploy all of the contracts. Yeah, Rust, go Rust. Come on, you can do it. Come on. Yeah, okay, cool. So it's compiling them, and now it's re-uploading them to all of our local servers. And we can actually watch, again, like it's kind of cool to see the file update. If you notice, like, okay, the code ID here changed to 1 and the addresses are getting updated. So, all of this deploy stuff is happening in the background. And now you can read in the README and see how it all works, but this deploy.json is used in on-chain tests, in the front end, in the deploy tool. Like it's used everywhere, and that's kind of the point, is it's all synced from that file. So you don't have to worry about like keeping things in sync. It just all works. Okay, so now it's nice that works, but if you notice there's this like IBC port, well, we actually have to tell the relayer about our changed port, right? It has to create new channels. Again, simple task. Task relayer, I think it's create channels local. Let's see if that's right. Yeah. So it's going to create the IBC relayer channels now. Why is that not working? Oh, because we completely wiped our Docker instances. So actually what we need to do is if we go back and we look at the README, I'm going to go over here to the README. We're kind of like at the very beginning, as though we were setting everything up from scratch. So what we actually have to do is relayer setup. And what that's going to do is it's going to create connections and clients and all that stuff. So task relayer setup local. And this is going to go through all the headache of the relayer stuff. It's going to take some time. So while it's doing that, let me go ahead and show some of the other cool stuff happening here. So first of all, everything is in Rust, including the deployer scripts, the on-chain tests. So if we look at on-chain tests, we can see that it's really, in Rust. The way it's working is it's using WebAssembly and bindings to Cosm.js. So if we look at, for example, this like wallet, like where is this wallet coming from? Well, it's this thing, this wallet instance, and this thing is, has bindings, and it's to Cosm.js. And this crate, this local crate in packages wallet, is actually it's used in the front end and in on-chain tests and the deployer, and actually it's also used in multi-test. The way it works is that there's this trait, and every wallet just has to be able to create like a a contract that implements these traits has a few very simple basic methods. Query, this is actually auto to write. You can see it has a default implementation. All it has to do is satisfy these two traits, query and exec and exec funds, and that's it. And then everything just works. So for the Cosm.js bindings wallet, it implements it through the FFI. And this is probably a lot to take in a video, but it goes through the bindings through the FFI, and these are all, in JavaScript, which is using Cosm.js. But for multi-test, we have the same sort of thing, but it's just, so it implements query and exec by calling the multi-test stuff. And so by doing that, now we get these shared traits, then we get all these methods everywhere. So we can call like exec send message and query info and query chat messages, all the app specific stuff. And yeah, that's super duper duper cool. Let's see if the relayer stuff is set up. Yeah. I think it also went through creating the channel. But you know what? Create a new channel. Great. Okay. But the typical flow when we after we deploy contracts, the typical flow would really be to create the channels again. So I'm going to go ahead and do that again. It won't take long. It's just like the more typical thing we do when we change contracts. So again, that is using this IBC port and setting it on the relayer. Okay. And this should be finished any second. And when it's done, we should be able to just run, so now we can restart the relayer. Let's do task relayer start local, right? Because we're doing it on the local chains. Great. And now let's bring up our front end. Local. What's going on here? Oh, I'm already running it in a different window. Whoops, I had a different terminal open. My bad. Let's do it now. Cool. Okay. So now if we do this on the window that we had before, everything would work. And you could see there's no more state here, it's all fresh. But let's go the extra mile and let's see what happens if we do it on a very brand new instance of Chrome. So you see we can't connect. So what we have to do is we have to tell it all about our local chains, which have these proprietary RPC ports. So it's actually very important to be able to have this functionality, because otherwise it would have no idea of how to connect to these chains. I have to go through this little song and dance. It's going to kind of prompt us a bunch of times for doing all this. And then once we have it, boom, we're in. How cool is that? So yeah. Yay, it works on brand new everything, right? And the relayer should be relaying all these packets. And it all comes across. So yeah, again, we literally just completely wiped everything, all the Docker instances, everything, created brand new chain instances, relayer connections and clients and channels, redeployed contracts, got new addresses. Everything is all synced together. And as an example that everything is all synced together, again, we could, run local IBC chat. Yeah, we could run test. By the way, I just want to show off-chain, of course, also works. But no need to show that. It's just doing multi-test, which is interesting, but it'll recompile things. So let's do on-chain first. Test on-chain local. And we can see that it should pick up the same deploy settings, the same address and everything. So we should, again, see it coming through on these contracts, right? It's rebuilding the tests. And 1 second. Server does not have all clients connected. All right, what's that about? Okay, this is probably failing because earlier we tried creating the channels because we forgot that we had wiped all of the everything. And we tried creating channels when we didn't yet have the client and connection on the relayer. So I think now that we've created the client and connection and all that, we should now redeploy the contracts, get a new IBC port, and then create the channels. And then everything should just work. Contracts, deploy local, and then after that's done, relayer, create channels, local, whatever. So yeah, we'll let it go through that process. Okay, cool. And then let's restart the front end. It'll pick up the latest deploy.json, and then we can release relayer start. Task relayer start local. Okay, all right, so it's picking up all of those, and then we should be able to test on chain local. Okay, this should work now. It's recompiling because we have a changed deploy.json. So it's importing that and recompiling stuff. So that's kind of what we want to see here. And hopefully it'll all just work. Yeah, cool. And now if we connect our front end, we'll start seeing all the stuff coming through from the tests. Yeah, so exactly. Yeah, it's all happening. So yeah, Stargaze, it's all pushing through everywhere. So that all works. Yeah, it's all working. I just had to redeploy the contracts and recreate the IBC channels. Sometimes things are finicky, or maybe I just did things out of order. All right. Last thing I just want to point out is this one more thing about it all being in Rust, which is really kind of cool, is events. So I mentioned that this window is just showing events, right? It's just querying every block and parsing out the transactions and the events from the transactions. But how does it get it into this well-typed formatted thing? So if we search for chat message event, we can see it's defined in this shared, let's see, where is it? Yeah, it's defined in this shared crate, which is used in the front end, in the contracts, everywhere. So it actually has a try from impl for event. So it kind of knows how to, it looks for the type. It sees if the type has the right key, the same key that it was set to create the event. It's all just well typed in Rust. And because it has try from, so in the server, when it parses out the raw events, it can then just do, where is it? Raw event. Oh, first it checks if it's from our protocol, as it were. But here it's in this right here, right? The try from. This contract kind thing. This is just kind of whatever. It's not a requirement. It's just the way I like to write contracts. And so within each contract, it gets this response builder. And so here it has it adds standard events to every event. So we know which events are ours and which events are from other contracts and stuff. But yeah, the cool part there is, of course, that it that it knows how to parse out the chat message event, and once it has that, it has a real the real thing. And then of course in the front end it can whatever do all the magical cool stuff and actually use the event, which happens to be, just for the sake of completing that, it happens to be here. It gets the chat message and displays it. So yeah, that's it. Thanks for watching.